All right. Oh no. You can beat to this. See if I can do it. Uh-oh. I do like that song. All right. All right, here we go. We are looking at transformations. This time, this is deja vu from yesterday, because this time it's horizontal, right? So before, remember, we were looking at flipping the rubber band, stretching it up and down. We were doing a vertical stretch. I can do it. Yes. We were doing a vertical stretch where we stretched up and down, then we squished it, and then we flipped it. Okay. So today is just, it's harder to do. It's stretching it out, compressing it, and flipping it this way. Okay? And really, it's going to be the same thing. We're going to look for our K factor, which is going to tell us what's happening. We're going to graph it using technology. So the thing here, and this should make sense from yesterday, remember before we were transforming it up and down along the y-axis. If we're going horizontal, what value are we dealing with, x or y? If it's side to side.
X.
X, side to side, right? So since horizontal transformations involve x values, we are going to modify f of k times x. So instead of putting the k and multiplying it times the entire f of x, this time we're multiplying that k factor to the x value. To the x value. Okay. So one key thing, this is really important, in fact, underline this, the y-intercepts and the y value of the vertex stay the same. So if I, for instance, was going to, let's see, if I'm going to stretch this, or compress it, sorry, if I'm going to compress it, we end up with the same y value for the vertex. All we're going to do is, we're going to stretch it or compress it. Okay. So we're just compressing it or stretching it horizontally this time. Same process we're going to do, except now we're just applying the k value to the x. So watch what we do. F of x right here is x squared plus 8. Before we were multiplying k times everything, but this time, since k is 2, what we're going to do is multiply the 2 into the x value. So really what we're taking then, just like the warm-up, we're taking f of 2x. Okay. Remember, whatever is in here in the function notation, we evaluate. We substitute it in for wherever our x value was. So since it's f of 2 of x, I'm going to go ahead and take the 2x and put it in for x right here. Look what happens then. 2x takes the place of x, 2x squared plus 8. So remember, 2x squared is just 2x times 2x. What does that give us? 4x squared plus 8. Okay. Really, it's deja vu, having deja vu. Because now we have our new function. This is f of 2x, which is the translated function. So this second function is what we did, what we are going to graph and compare to our original function. Just like yesterday. We apply that 2 inside the function here, which tells us, yeah, we substitute 2x. Whatever's in here, remember, we substitute in for x and then work it out. Okay? So now we're going to just kind of review what we did yesterday because it's going to be very similar. So let's look at this. When we have a horizontal stretch, we end up having a k factor that is a fraction or a decimal. Really deja vu, right? So if I had a graph that had a horizontal stretch, it's stretching it towards the sides, right? We know that if we had, say, a function like this, let's go ahead and put it in orange. We know that we're going to have the same y-intercept. It's not going to go through the same x-intercepts because it's being stretched or compressed. So what we'd end up with is something that looks like that. You see? It's being stretched along the horizontal axis. It stretches that way. Okay, stretches. So just like yesterday, the K factor tells us what is going to be the difference between all of these different types of transformations. So the next one we just have when K is greater than 1. And what do you think is going to happen if we compress it? Here, when we stretched it, they moved out because we stretched it horizontally. What's going to happen when we compress it horizontally? Let's see. Here's the original function. We know that the y-intercept stays the same, so, and the y value for the vertex, so what we end up with is just a compression. I mean, we can even put the arrows pointing in like that to show us that it's getting squished towards the y-axis here, squished in. Okay. Now, the last one we have to do, and this is the same as yesterday, because we have a reflection when we have a negative number. When we have a negative number, we get a reflection. So watch what's going to happen here. If I'm over, like so. Okay. Remember that here we're talking a horizontal reflection is just over the y-axis. It's as if you took the piece of paper and you folded it this way, right? So one thing I do know is that the y-intercept is going to be the same. That's for all these type of problems. Y-intercept is the same. I know that the y value for my vertex is the same. So I know that, if this is down here at 2, my other vertex is going to be about there. And then we can make our graph like that. You see, it's just taking the whole thing, it's flipping it over that y-axis. That's all we're doing with that. Okay, so let's see. Oh, let's go ahead and do this example problem then. So go ahead and peek over here. We're just going to do this one sample problem. I think after doing yesterday's problems, we can see where we're going with this. You see the table on the right? That's basically, even the classwork looks the same. I gave you the same table. I even gave you the same functions from yesterday because we're not doing the same trick. We're doing the horizontal shift, so this -3. Watch what we're going to do with this. So first off, I know that I'm looking for this. I'm looking for taking the k value and multiplying it to whatever the x is. So let's just refine that. Let's go with -3 is our k, so watch -3x. Now, I'm just going to put these like this. If you had a hard time kind of conceptualizing when I plugged in that -3x, I want you to set this up just like this first. So set it up where the x value is just open here with parentheses, because then what are we going to put right here? What do you think? Raise your hand. What do you think? -3x. Whatever in function notation is in the parentheses here, whatever it is. Like I said, it could be a logic problem where it's star, it could be square. It doesn't matter what it is. We take that value, whatever it is, we put it into our x value over here. So let's see what happens. Yeah, because this is -3x times -3x. -3 times -3 is 9. X times x is x squared plus 2. Now I have my new function here. This is my -3x. So we had our original. We have our new one. We use Desmos or a graphing calculator to compare those two. Okay? But first off, let's start to answer some of these questions. They're going to be very similar every time. Same questions were asked. Is this a stretch, a compression, or a reflection? And tell me why. Raise your hand for this one. What do you think? Think about it for just 10 seconds or so. How do we know if it's this, or this? How do we? So let's look. When k is a fraction, we get a stretch. When k is greater than 1, we get a compression. When k is less than 0, so when it's negative, we get a reflection. So what do you think?
Reflection.
Reflection, right? Reflection. So we just have to look at the table here to figure out what's going on. In this case, I know that this is reflection. Okay? Because it's negative, this is negative. Because it's negative, I know that has to be reflection. You get that right?
I got it wrong, but you get it right.
I corrected.
Nice, nice. In-class tutoring?
Yeah.
Perfect. All right, let's see. When we graph these, okay, I'm gonna do like a mental Desmos here. So this is 1, 2. Our original is here. I'm not even gonna do a table because then everyone sees table and they start to get jittery and worried. But I'm just gonna plug in some values in my head here. So we still have some of these shared. Okay, we plug in 1, we get 11. Okay, we plug in -1, we also get 11. So we end up with, whoa. Oh, oh, this is fun.
Oops.
Oops.
It does.
One sec, I'm gonna pause it. Just to double check. All right, we're back. Our new graph is gonna look like this because why do you think, if you really think about this, it's reflected over the y axis, correct? Well, what else is happening to my dashed line compared to my solid line? It's been a compression, right? Because my factor isn't just negative, but it's 3 as well. So the compression is going to also play into it. It's as if we're applying a 3 and a negative value. So we end up having a reflection, but we also have a bit of a compression. Now I think you'll start to see those trends as you work it out with technology. Remember, I did this kind of table in my mind here, but you're going to use Desmos and see the differences with that. Okay, so don't worry if you're not quite seeing how those two things are happening at once here. Trinity?
If it's both of them, then
Right.
which one would you like us to put in the
Right, right. So because it is a negative number, the primary thing that's happening is a reflection.
reflection?
Yeah, but what I'm saying is there's going to be moments where parts of them are both involved. Okay, so we're going to go ahead and go with reflection. Does it have a new vertex in this case? Look at both of those. What do you think? No. So we still have the vertex at 0, 2. All right. In your own words, I would say that there was a reflection over the y-axis and also a compression. Okay. To graph this, I just graphed it right there. So you see, we can do that. We can do the graph. And that's what we need to accomplish today. Right. So whatever your k factor is, that is also manipulating how much it's compressed. So if I had a k factor of, say, 10, right? Compared to the original, the new compressed parabola would have a scale factor of 10 smaller, right? It would be squished by a factor of 10. If it was positive 2, it'd be squished by a factor of 2. So it'd be halfway closer to that y-intercept. But these are things that, after you start to use k enough, compare the two graphs and look to see, okay, how much did it shrink? How much did it compress? If it was a scale factor of 2, it compressed, really, you can think of it as a half. It's a half. Okay. Any questions on this one? Is this deja vu? Do you guys kind of remember yesterday and how it's really similar? The only difference is, instead of multiplying all of f of x by our k, now we're just going to apply that to whatever our x value is, substitute it, work it out to our new equation, compare them. Okay? So that's where we're going today. All right. So does anybody have a shout out? Anyone's mom's birthday or something?
Oh, my mixtape.
All right. You want to give a shout out for your mixtape?
I'm going to do
You want to give a sample or a rap? We can beat to it.
Yeah.
You've done it before?
Pre-order it first.
Pre-order
I want
first.
shirts.
You need to give a teaser though, so that they know.
It's the
Yeah, you have to use
intro.
It's the outro.
Oh.
Oh.
Do it, guys.
Come on.
I need music.
We need some beats. Beat makers. Noah. Beats. Hit it.
Pressure's off. Pressure's off.
All right.
Okay. This is Mr. Pasillas back in class, and if you miss a lesson, just chill and relax. Because Monday through Thursday posts on the daily, and when you're done watching, you can go show the ratings.
Oh, that was good. Don't forget to subscribe. 79th gets a cookie or a Kit Kat, whatever I said.